Alright, this is section 8.1, so the last chapter, first section. So this is going to be all about complex numbers. All of you have seen complex numbers at some point before, so hopefully some of this is just a refresher to your memory. Before we kind of get started, I just want to kind of go through a couple of very simple radical things. If you guys take the square root of -1 on your calculator, you know that that's an error, but hopefully in your previous math classes, you know that the square root of -1 actually comes out as the imaginary number I. Okay, so if you have the square root of any negative, just know that that can come out as an I. So if you have a problem like the square root of -12, we can rewrite inside as what? -1 times 4 times 3. And you could even break down the 4 as 2 times 2 if you so desired. So now, if you kind of bust all of them up, the square root of -1 we already know comes out as an I. The square root of 4 we know can come out as a 2, or there's a pair of 2's that can break out. So 2I comes out. The 3 has to be left inside the radical, so it ends up being 2I times the square root of 3 if I want to simplify these things. Okay? Now here's the real fun one. Do not write the square root of 48, because you're going to end up getting it wrong by default, because you can't just have those negatives multiply by each other and go away. Evaluate your radicals separate. Okay? Get the negatives outside at least, because we now know that the square root, if I go -1 times 6 times the square root of -1 times 8, I know this I can, or this -1 can come out as an I. This -1 can come out as an I. So this could be I times the square root of 6 times I times the square root of 8. You have to take those I's out. Okay? I times I is I squared, and then you can dump your radicals together. So the square root of 6 times the square root of 8, a lot of you know, is the square root of 48, but you cannot lose that I squared. Okay? Now what is I squared? For those of you that kind of forgot, okay, I squared ends up being -1. Because what's the square root of -1 times the square root of -1? If I know that I is, so I times I. Okay, two radicals multiplied together, you just get whatever's at the end. So it's -1 times the square root of 48. And then how do you bust 48 down? Well, 48 can be 16 times 3. So the square root of 16 is 4. So -1 times 4 times the square root of 3 has to stay. And you can simplify a little bit as -4 times the square root of 3. Okay? So just once again, remember, if you have a bunch of radicals, make sure you get the negative signs out first, because if you just write it as a square root of 48, you're going to lose your negative sign. Alright? So just make sure you take your I's out appropriately to start with, and then there's really no trouble after that. If I give you a scenario like this, alright? So the general form for any imaginary or complex number is A plus BI. A refers to the real part. Alright, the BI refers to the imaginary part. Alright, and when you're solving a problem or an equation, something like this, you just deal, okay, what do the real parts have in common, or that's what you look for. So you can literally say 3x equals 24, because the real parts has to deal with the real parts, the imaginary deals with the imaginary. There's no real ifs, ands, or buts about that. So to solve this, just divide by 3. So x must be 8. And then you do that for the imaginary part. -2yi equals 18i. And you don't even really need to deal with the i's, because that's just saying that they're imaginary. So -2y equals 18. Solve, so y must equal -9 if you just divide that -2 over. So that's how you solve for x and y in this complex equation. Alright, we're going to do a bunch of operations. Literally going to do all 4 operations. I'm going to do one problem adding, subtracting, multiplying, and dividing. And then we'll kind of call it a day for that part. Now the adding, just like I kind of just did, refers to literally the things that are in common. Your real parts you can add together. So what is 3 plus the -2? And that's going to end up being just a 1. And then you're going to have your 5i plus a 7i. And that ends up being 12i. And you want to write it real part and then complex part, or the imaginary part. So we have 1 plus 12i for that addition problem. Okay? The subtraction problem. Alright? Just remember, you have to subtract the 2. So either distribute, so then you can add, or else go the 6 minus the minus 3. And that ends up being 6 plus 3, which is 9. And then negative 7 I minus 5I. So negative 7 minus 5 ends up being a negative 12I. Alright, so that ends up being your subtraction part. Okay, now let's flip it to multiplying. No, this is just using FOIL. You have to FOIL this out, and then you're going to have to use some of the rules that we talked about before. So FOILing goes first times first. So you're going to see 4 times 6 plus outside goes 4 times 4I. So that's outside. And then we got to go inside. Minus 3I times 6. And then minus 3I times 4I. Alright? And then you just got to simplify. So I have what? 24 plus 16I minus 18I minus 12. I times I is I squared. Alright, what can we now combine or deal with? Well, I know that I squared has to be negative 1. So if I kind of do this math here, 24 plus 16I minus 18I minus 12 times negative 1. Okay, so now I know that this ends up being 12, positive 12, because negative 12 times negative 1 is a positive 12. So 24, and you don't have to write all these steps out. I'm just writing them out to try emphasize and show you what's going to end up combining. You now can combine your imaginary parts, or the i's. So 16 minus 18i. And then you also can combine your 12 and your 24, the real parts. So 24 and 12, and I want to write the real parts first. So 36, and then 16 minus 8 is 18 is minus 2. So 36 minus 2i. So when you multiply, you got to FOIL it out. Just know that anytime you have I squared, it's negative 1. And then just combine your reals and combine your imaginaries. Now when you're dividing, you cannot have an imaginary number on the bottom. It's kind of like you can't have a radical on the bottom. Same principle. Complex conjugate is the idea that we want. And I look at the bottom. Complex conjugate just means that you just change the sign. So I'm going to multiply top and bottom by the conjugate. Alright? So 1 plus 4i. So what that's going to end up doing is on the bottom you should get just a number. And on the top it's going to look very similar to what we just got done doing here. So you kind of tie it all together. So let's look at just the top. The top, if I FOIL it out, I end up having 5 times 1 is 5. And I'm not going to write out all the steps this time. The outside is 5 times 4i plus 20i. Inside is 3 times 1, or 3i times 1, excuse me. So 3i. And last times last would be plus 12i squared. Okay? And then that's going to be over. If I do the same thing for the bottom, 1 times 1 is 1. Outside and inside would be a plus 4i and a minus 4i, but those should end up canceling out. And that's the goal behind it. That's why we do the complex conjugate. Negative 4i times a 4i is minus 16i squared. And now you need to simplify both the top and the bottom. So what do I know about the top and the bottom that can be combined? Well, I know that this I squared in both spots can have a negative 1. Alright? So now the top, I know my i's can combine for 20i and 3i would be 23i. This right here is a negative 12. So 5 minus 12 ends up being on the top a negative 7. The 20 and 3i can add together to be 23i. So that's just the numerator, the top. Alright? Now in your denominator, the i's better go away. Now that's what I meant by the outside and inside are gone. Okay, negative 16 times a negative 1 is a plus 16. Plus 1, so you end up getting 17 on the bottom. And there's a variety of ways that you can write this. You could write it like this, or you could split it up into your real part. So negative 7 over 17 is your real number, plus the imaginary is 23i over 17. Either of them are acceptable. They mean the same thing. Alright, it's just whether or not you want to split them up or not. So that's your definition of dividing, just remember you have to do your complex conjugate and then do your multiplication accurately. Okay? Here's the last ones, and this gets a few people kind of caught by surprise. Okay? When you guys try and do this, my point is find the closest number that 4 goes into. The reason for that is this. We all know that I is the square root of negative 1. And we know that I squared is negative 1 because you multiply those together. Well, I cubed would be simply these two multiplied together. So it would be negative, maybe I should write it like this. This may be a bit better. I squared times I. Hopefully you guys can follow that. And then you know that I squared is negative 1, so it's negative I. And that's the idea. So I is just I. Okay, I squared is negative 1. I cubed would be a negative I. I to the 4th is what? I squared times I squared, which is negative 1 times negative 1, or 1. So what's kind of nice is, for instance, number 6, if you see I to the 4th, I know my answer is 1. Okay? And what I mean by you trying to find the closest number that I to the 4th goes into, or 4 goes into, a multiple of 4. So if I start counting by 4, 4, 8, 12, 16, 20. For instance, I to the 20th power would be I to the 4th multiplied together 5 times. Well, 1 times 1 times 1 times 1 times 1 is still 1. So if you can get a number that's a multiple of 4, the answer has to be 1. So for instance, number 8, when I say I to the 8th, that shows up. Okay? I know that that's going to be a 1 as well. And then what I mean by find the number smaller than that's closest to, or a multiple of 4, I to the 5th, for instance, well, the multiple smaller than it that 4 goes into is I to the 4th. And then how many more do you need to get I to the 5th? Just one more. Well, I to the 4th I know is 1, so it would be 1 times I. So what's your answer? Just I. Okay? I to the 6th would be like I to the 4th, the one smaller than it, times how many more do I need? I squared. Well, I know I to the 4th is 1 times I squared, I know is negative 1. What's 1 times negative 1? A negative 1. Okay? And that's kind of the process I want you to take. So when I end up throwing out something at you like I to the 39th power and give me that answer, oh my goodness. Absolutely sucks, right? Well, find a number smaller than it that 4 goes into. So if you start counting by 4s, or if you keep going, hopefully some of you are saying, hey, 36 goes into it. Okay, that's the number smaller than it that 4 is a multiple of. Okay, so I can say, all right, I to the 36 times, how many more do I need? Well, I to the 3rd. Sweet. I know that I to the 36 has to be 1 because 4 goes into it. That would be like multiplying I to the 4th together 9 times. And 1 times 1, or 1 times itself, 9 times is still 1. And then what did we talk about? I to the 3rd is just negative I times a negative I. And that would be your answer. So the trick is, as long as you can remember these first 4, you literally can do any of them by just thinking about, okay, what number does 4 go into closest to my answer? Okay? So one more, for instance, I to the 94th power. If I mean like that, I can give you something just that massive. Think about, okay, 4 I know goes into 80 for sure. So 84, 88, 92. Okay, so 4 goes into 92. So I can say, all right, I to the 92nd power times I to the, how many are left? 2 more to get to 94. So then 1 times negative 1, your answer would be negative 1. So that's just an example of how I can make a very, very large values become relatively simple going back to the original 4, or first 4 in line. So as long as you can remember those, you can do any of these. Alright, so that is it for this section. We're actually going to have a worksheet that we're going to work on tomorrow, and I hope you all have a wonderful day.